This is the Pre-Calculus Chapter 4 test review. Find the exact values of the 6 trigonometric functions for theta. To do this, the first thing you need to do is, if this is your angle, we need to label our sides. Remember, the side across from the angle is the opposite. The side across from the 90 is your hypotenuse. And the side that's between the angle and the 90 is the adjacent. Now, our 6 trig functions are sine, cosine, tangent, cosecant, secant, and cotangent. Now, sine is opposite over hypotenuse. On this triangle, our opposite side is 30, and our hypotenuse is 35. Cosine is adjacent over hypotenuse, or in this case, 5 radical 13 over 35. And our tangent is opposite over adjacent, which is going to be 30 over 5 radical 13. Now, we need to do some simplifying, and we need to get a radical out of the denominator. 5 goes into 30 and into 35. 5 goes into 30 6 times. 5 goes into 35 7 times, so we can reduce sine to just be 6 over 7. On cosine, 5 goes into itself once. 5 goes into 35 7 times. So we can just reduce this to be radical 13 over 7. 5 goes into itself once. 5 goes into 36 times. But we still have a radical in the denominator. We need to multiply the top and the bottom by radical 13 to get the radical out of the denominator. So we're going to end up with tangent being 6 radical 13 over 13. Now, once you have them in this form, to find the other 3 trig functions, you just find the reciprocal. So for sine, we are just going to have, if sine is 6 over 7, cosecant will be 7 over 6. Since cosine is radical 13 over 7, secant will be 7 over radical 13. And if we go back to tangent, where it was 6 over 1 radical 13 before we got the radical out of the denominator, if we flip that, we'll just have radical 13 over 6. Now, the only one we're going to have to change here is secant, because there is a radical in the denominator. We will multiply the top and the bottom by radical 13, and that will leave you with 7 radical 13 over 13. Find the value of x and round to the nearest tenth if necessary. So if this is your angle, we need to identify which sides we have right now before we can start. So the side across from your angle is the opposite. The side between the angle and the 90 is the adjacent. So which trig function uses opposite and adjacent? That would be tangent. And tangent is opposite over adjacent. So the tangent of 29 degrees is equal to my opposite side over my adjacent side. Right now we have x divided by 40. So to get the x by itself, we need to do the opposite. And the opposite of divide is multiply. So we can multiply both sides by 40. So this means x is going to equal 40 times the tangent of 29 degrees. Now, before you solve this, since this is in degrees, you need to make sure your calculator is also in degrees. And if we do 40 times the tangent of 29 degrees, you should get that x is 22.2. This time we're going to find the angle measure, and we're going to round to the nearest degree. Again, we're going to start by identifying which sides we have. This side is across from the angle, so it's the opposite. This side is between the angle and the 90, so it is the adjacent. So again, this time we will be using tangent. Our opposite side is 10. Our adjacent side is 6. When you are looking for the angle, and you want to get that theta by itself, you will use the inverse. So to move just that tangent, we're going to do the tangent inverse of 10 over 6. When we're finding our angles, we're just going to round to the nearest degree. You do need to make sure your calculator is in degrees, and you should get theta is 59 degrees. Both Derek and Sam are 6 feet tall, and they're looking up at a 10-foot basketball goal. So here is our basketball hoop. We know that that is 10 feet tall. And we have 2 basketball players who are both 6 feet tall. We know that the angle of elevation from Sam to the goal is 31 degrees. And we know the angle of elevation Derek is 31 degrees. Sam is 48 degrees. Now, if the basketball hoop is 10 feet tall, and we know the boys are 6 feet tall, the difference that is left for this triangle is 4 feet. I can call X this distance from Sam to the hoop, and we can call Y the distance from Derek to the hoop. We want to know how far apart the 2 boys are standing, so we want to find this value right here. So first we're going to start by finding the X and the Y values. To do this, we're going to use your trig functions. So if this is our angle and this is our angle, the side over, that's the 4 feet, is the opposite side. The X and the Y are both going to be the adjacent side. So for both of these, we are going to use tangent. So for this red triangle here, we know that our angle is 48 degrees. We know the opposite side is 4. We need to find the adjacent side. The first thing we need to do is multiply both sides by x to get that out of the denominator. So we're going to have x times the tangent of 48 degrees is equal to 4. Now, since this is x times the tangent, to get the x by itself, we're going to do the opposite, which is divide. So we're going to divide both sides by the tangent of 48. So we know that side x is going to be 4 over the tangent of 48 degrees, or x, in this case, will be 3.6 feet. For the blue triangle, we're going to do the exact same thing. This time I'm going to say the tangent of 31 degrees is equal to our opposite side over our adjacent side. Again, that y is in the denominator. We're dividing by y, so the opposite of divide is to multiply. So I know that y times the tangent of 31 degrees is equal to 4. To get the y by itself, because right now we're multiplying, the opposite of that is dividing, so we will divide both sides by the tangent of 31 degrees. And we're going to get that y is equal to 4 over the tangent of 31. If you put that into your calculator, you are going to get that y is equal to 6.7 feet. So if I know this blue distance is 6.7 feet, and I know the red distance is 3.6 feet, to find this distance right here, we can take the 6.7 and subtract the 3.6. So to find the distance between them, we can do the 6.7 minus the 3.6, and we're going to find that the boys are standing 3.1 feet apart. We need to write this angle that is currently written in decimal form into degrees, minutes, and seconds. So the first thing we do is anything that's in front of the decimal, we just write as our degrees part of this problem. So I have 141 degrees. Now we are going to take your decimal and we're going to multiply it by 60 minutes because there are 60 minutes in every degree. When you multiply this, we are going to get 32.94 minutes. Again, anything that is in front of that decimal, we're going to bring down. That's going to tell us exactly how many minutes we have. Everything that is after the decimal, we are now going to write down here, so 0.94, and we're going to multiply it by 60 seconds because there are 60 seconds in every minute. And when you multiply this time, you're going to get 56.4 seconds. So 141.549 degrees is actually equal to, in degrees, minutes, and seconds, 141 degrees, 32 minutes, and 56.4 seconds. We need to name one positive and one negative coterminal for the given angle. So remember, to find one positive and one negative coterminal, you're always going to add 2n pi, where n can be any integer, positive or negative. So we're going to take 2 pi over 3, and I'm going to add a positive 2 pi, and I'm going to take 2 pi over 3, and I'm going to subtract or add a negative 2 pi. Now, 2 pi can be written as 2 pi over 1. Now, why are we adding 2 pi? Remember, a whole circle is equal to 2 pi in radians. But before we can add fractions, you need to make them have the same denominator. So since 2 pi over 3 has a denominator of 3, we're going to multiply that 2 pi on the top and the bottom by 3 so we can get the same denominator. So this is going to give me 2 pi over 3 plus 2 pi times 3 gives me 6 pi over 3. And we're going to have 2 pi over 3 minus 6 pi over 3. Since the denominators are now the same, we can add and subtract our fractions. And 2 pi over 3 plus 6 pi over 3, 2 plus 6 gives me 8 pi over 3 as my positive coterminal. And 2 minus 6 will give us a negative 4 pi over 3 as our negative coterminal. We need to find the length of the intercepted arc given this information. Now, to find the length of your intercepted arc, it is r times theta, but it is key to remember that your theta always has to be in radians. So if your theta is given to you in degrees, your first step will be to convert from degrees to radians. If it's given to you in radians, you can just plug everything in. So we know our radius is 2.5. We know our theta is pi over 6. So our arc length will be 13.1 centimeters. Find the rotation and revolutions per minute given the angular speed. So right now I have 140 pi radians in every 1 minute. We just want to get these to revolutions per minute. So we're just converting the units from radians to revolutions. Since radians was on top, we're going to put radians on bottom so we can cancel those units. And remember, for every 1 revolution, or every 1 turn around the circle, that would be equal to 360 degrees, or in radians, 2 pi. So this radian will cancel with this radian. The pi on top will cancel with the pi on bottom. 2 goes into itself once. 2 goes into 104 52 times. So if we multiply straight across, 52 times 1 gives me 52 revolutions. 1 times 1 gives me 1 minute, or we're doing 52 revolutions per minute. We need to find the area of the sector. To find the area of a sector, we're going to do 1/2 r squared times theta, where again, your theta has to be in radians. If your theta is not in radians, you will have to convert this first. So since our angle is given to us in degrees, we will have to convert that before we start. Remember, if you have an angle in degrees, to convert it to radians, you're just going to multiply by pi over 180. Now, if we want to simplify this before we go any farther, 2 goes into 146 73 times, and 2 goes into 180 90 times. So if we multiply straight across, we're going to get a radian measure of 73 pi over 90. So we're going to use that as our angle instead of that 146 degrees. Right now we know the diameter is 21.4. So to find the radius, you're just going to cut that in half, and we're going to get 10.7. So to find the area, we're going to do 1/2 of that 10.7 squared times our theta, which is 73 pi over 90, or the area of our sector will be 145.9 kilometers squared. We need to find the exact value of the expression. Now, we're going to be using the unit circle on this. And cotangent, remember, is x over y. So if we look at our unit circle at 11 pi over 6, when we look at 11 pi over 6, our x value is radical 3 over 2, and our y value is negative 1/2. So our x value was radical 3 over 2. Our y value is negative 1/2. Remember, when you have a fraction over a fraction, the first fraction will stay the same. The second fraction you're going to flip upside down, and you are going to multiply. Now this 2 will simplify to be 1. This will be 1 because 2 goes into both of those one time. If we multiply straight across, radical 3 times negative 1 will give me negative radical 3. 1 times 1 is 1, or we can just write this as negative radical 3. We need to find the exact values of the 5 remaining trig functions. Cosine, we know, is negative 1/2. Now, it is key to remember that cosine is x over r. But we do know that r always has to be positive. So we know that x will equal negative 1 and r will equal 2. We have the formula that says r is equal to the square root of x squared plus y squared. Since our r value is 2 and our x value is negative 1, we can use this to solve for y. Now, to get rid of that square root, we can square both sides. So 2 squared gives me 4. The square root is now gone because we squared both sides. Negative 1 squared is 1. To get the y by itself, we can subtract 1 from both sides. So we know that 3 is equal to y squared. To get the y by itself, we can take the square root of both sides. But remember, when you take the square root, it can be positive or negative. And that's when we're going to come up here to see which one our answer should be. We know that sine is the y coordinate, and we know that the sine of theta should be greater than 0, which means our answer has to be a positive y value. So now we know that x is negative 1, we know r is 2, and we know y is a positive radical 3. So let's find our trig functions. In terms of x, y, and r, sine of theta is equal to y over r. Cosine of theta is equal to x over r. And tangent of theta is equal to y over x. So for sine, we're going to have radical 3 over 2. For cosine, we're going to have negative 1/2. And for tangent, we're going to have y over x, which is going to be negative radical 3 over 1, or radical 3 over negative 1. Remember to find the other 3 trig functions, cosecant, secant, and cotangent. We can just find the reciprocals of the first 3. So cosecant will be 2 over radical 3, secant will be 2 over negative 1, and tangent will be negative 1 over radical 3. But remember, we cannot leave a radical in the denominator, so we will have to multiply the top and the bottom by a radical 3. So this will give me 2 radical 3 over 3 and negative 1 radical 3 over 3 for cosecant and cotangent. We need to state the amplitude, the period, the frequency, phase shift, and vertical shift, and then we need to graph the function. So let's first identify A, B, C, and D. Remember, A is the value that's in front of cosine or sine. In this case, it'll be 1. B is the value that's in front of x, which in this case will be 1. C is the value that's either added or subtracted to x, so in this case it's going to be negative 3 pi over 2. And D is the value that's added or subtracted at the end, so our D value is negative 1. Your amplitude is just your A value, which in this case will be 1. Your period is 2 pi over the absolute value of B, which will be 2 pi over 1, or just 2 pi in this case. Your frequency is absolute value of B over 2 pi, or 1 over 2 pi. Your phase shift is negative C over the absolute value of B. Our C value is negative 3 pi over 2, so a negative and a negative is going to turn that positive. Our B value is 1, so this will just simplify to be 3 pi over 2. And your vertical shift is just your D value, which in this case will be negative 1. The other thing that you can find that can make this easier to graph is to find your interval, which remember is period over 4. Our period is 2 pi, so 2 pi over 4 is going to give us pi over 2. So if we come down here and we go to graph this, I'm going to make mine every pi over 2. And let's make this 1 here. Let's change that. Let's make this 1 and 2. And let's make this negative 1 and negative 2. Now we're going to start by looking at our vertical shift first. We do have a vertical shift of negative 2. So instead of our midline being the x-axis, our midline is actually going to be at negative 1. So this is going to be the line that our graph oscillates around. Now cosine usually starts at 0 and its high point, but we do have a phase shift. So instead of starting at 0 in our high point, we're actually going to start at 3 pi over 2 in our high point. Our amplitude is 1, so we do need to go 1 unit above that midline. So I'm going to start at 3 pi over 2 and my highest point, which is 1 unit above that midline. Now with cosine, we're going to look at our interval. It tells me I'm going to change every pi over 2. So every pi over 2 units away from that, we're going to change. So if I start at 3 pi over 2, pi over 2 units away, I'll be at the midline. The next pi over 2 units away, I'm at the low point. Then I'm back at the midline. Then I'm high. Since I was high, this is midline, low, midline, high. Once we have this, we can just draw our cosine function in. And this would be the cosine of x minus 3 pi over 2 minus 1.